Good afternoon, everybody. Welcome to, I hope it's going to get warmer soon, Monday afternoon for Chem 170 with your host, me, Dr. White. All right, important information. Don't forget, this Wednesday after lab, I will be sending out the password for the PDF file for test number 4. And you'll have until 11 o'clock Thursday, 11 o'clock a.m. to take test number 4 and hand it in or upload it as a single PDF file like you've been doing for the other tests. Now, I think I have taken an hour and a half or 2 hours, take 2 hours. Either you know it or you don't. Obviously, don't cheat, but that will be test number 4 this Wednesday, due on Thursday. All right, also this Thursday is the deadline. Notice deadline, can't go over it or you can't hand it in. And that's for the extra credit project. Remember, the extra credit project is 10, yes, 10 points. However, it's optional, but I would think it would be a good thing for all of you to do it. And before Thursday deadline, if you want, email me your project. I'll take a look at it and tell you what's wrong so you can correct it and get your 10 bonus points, which will help. It can't hurt. Even if you're doing good, it's good to have 10 extra points in the bank, so to speak. All right. Today, before we start, I was just thinking, we only have 2-4 this week and next week left together. Boy, did this semester go boom. And then we'll have finals week, which ECC doesn't have an official finals week, but that's when I'll have the final, that Monday. I have to change it in the syllabus. I keep on forgetting to do that. And our time's up. Try and get all your labs in. And if you're planning on sometime in the future asking me for a letter recommendation, I highly recommend before the end of the semester, either come to my office hours so I get to know you a little, or set up a meeting via Zoom so I can talk to you and find out who you are. And with that, what we'll do today is 1, I'll do the review for the next test, test 4. I have to get that fixed one day. And then we'll do the problem set for the carbohydrates, carbohydrates, and then new material that won't be on test 4, but will be on the final exam some points. So with that, let's get started. All right, thumbs up, people. Everybody see carbohydrate practice problems. Thank you, Vivian, Danielle, and let's get going. Now, Dr. White's getting lazy. It's the end of the semester. What's a carbohydrate? You should know that's a polyhydroxyl ketone, polyhydroxylaldehyde, or a molecule upon hydrolysis becomes a polyhydroxylaldehyde or polyhydroxyl ketone. All right, number 2 is each of the following items chiral or achiral. Chiral means non-superimposable mirror image. Excuse me. Achiral means without chirality, handedness. Remember, chiral means handedness, and that means has a superimposable mirror image. Now, if we look at A, left foot, as soon as you see left or right in the description, immediately know it's, like your hand, chiral. So your left foot is chiral. If you don't believe me, put it in front of the mirror and you'll see your right foot in the mirror image, and it's non-superimposable on your left foot. All right, mitten, no leather bound. Well, guess what? It has a superimposable mirror image, but also you can put it on either hand, so it's achiral. A tube sock, no design or writing, I should have also put down no toes. You know how women's tube socks, some of them have the toes. No, those are my fingers, but you get what I'm talking about. But without any of that, tube socks, like what I'm wearing now, are achiral. And remember, achiral means superimposable mirror image. You can do that. Or, as you know, you can wear those on either foot or either of your feet. Sewing needle, superimposable mirror image, achiral. Piece of rice, that's going to have a superimposable mirror image, and that's achiral. Now, this one I probably shouldn't have put on a test, but I put it here, and that is the baseball glove. And if you haven't played baseball, you don't know, you can either get a mitt for your right hand or mitt for your left hand. If you're right-handed throwing, you get a left-handed glove, which means the baseball glove can come either right or left. It's chiral. Your face, we did that in class, chiral. A car, we did that in class, chiral, on superimposable mirror image. Oh, that tea's good. Blueberry this afternoon. All right, next, number 3, circle the chiral carbons. Now here, what's a chiral carbon? A chiral carbon is a molecule, or carbon, not a molecule, bad Dr. White. A carbon has 4 different groups, 4 different atoms, or a combination of 4 different groups and atoms. If you have 2 or more of the same group or atom on a carbon, it can't be chiral. And if it's in a double bond or triple bond with another atom, it can't be chiral. So CH3, CH2, CH3, boom, it can't be. That leaves us this carbon, hydrogen, chlorine, methyl, and these carbons right here. Guess what? 4 different groups, it's circled. Next one over here, we have chlorine, hydroxyl group, methyl, and these 3 carbons with a chlorine. 4 different groups or atoms, and that's why that's circled. Now, if we look at B, we have, oh, wait, CH3 out, CH2 out, carbons in double bond are out. That leaves you 1 carbon to consider, hydrogen, thiol group, methyl, and this is called the allylic group, which I didn't teach you, but it's what it's called. 4 different groups circled. Now, ooh, rings. Dr. White and Mother Nature love rings. I do. I had to click something off that was being obnoxious. Let me do one other thing. I didn't. There we go. Now, if you notice, this carbon on the ring is in a double bond to oxygen. That's out. Now, this carbon, this, and this, how many hydrogens? 2 bonds. Remember, there's 4 bonds to carbon, and 4 minus 2 is 2. So this carbon, and this carbon each have 2 hydrogens, which means it's out. This carbon, you can see the 2 hydrogens out. This one, you can see 3 out. So if we look at this carbon that's circled, it's got a hydrogen, ethyl, these 2 carbons of the ring, these 2 carbons, which are different from these 2, 4 different groups or atoms, it's chiral. And the same thing here, CH2, 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 they're out. CH3 out. Remember, if you have 2 or more of the same atom or group on a carbon, it's not ever going to be a chiral carbon. But we have these 2. And remember, there's a hydrogen there, methyl, these 2 carbons, these 3 with the alcohol, 4 different groups, circle. This carbon, hydrox group hydrogen, you don't see it, but it's there. These 2 carbons and these 4 carbons, including the methyl, 4 different groups. Oh, look, I got over. And here, this is an aldehyde, double bond to oxygen out, CH2, the rest are there. And same thing here. All right, let's look at 3. Draw the enantiomer of the following molecules. Oh, look how nice I was. I put down, when I say enantiomer, that means draw the mirror image of a chiral molecule. Oh, by the way, I never play games and give you an achiral molecule and you've got to write down there's no enantiomer. If I ask you to draw it, there is one. I don't play games like that ever on a test. And therefore, we draw the mirror image. You don't have to, but I like to, and good habits I won't change. If I had a mirror here, the aldehydes being a chiral carbon, you can draw it like this. If you wanted to show the mirror image, you could. You have 4 carbons, then at the bottom of CH2OH, that's a chiral. If you wanted to show the mirror image, that's fine. But the first carbon here, carbon number 2 with the hydroxyl group, is close to the mirror. Therefore, you'll see the hydroxyl group first, and farthest away hydrogen. Same thing for the next 3, and that's how you do it. Now, B, I had some fun, but I'll never put that on a test. Here I show you how to do it in 3 dimensions, but that won't be on a test. And similar C, draw the mirror image. Oh, I went D too. Gave you a lot of practice. Now, on this problem and on this test, you can either draw the structure or write the name of the starting material or the product. And again, you can either draw the structure or write the name. And therefore, slight change of pace for a couple problems on test 4. And that will be, you can either draw the structure or write the name. And the question is, what do you get when you react fructose and glucose and acid together? Well, you bring it together and make sucrose. What happens when you react a lot of glucose together with itself under acid catalyst? You make starch. Now, this is before I perfected making this more curved. Boy, I was pretty rugged back then. If you take this molecule, react with an alcohol, acid catalyst, what is this? It's a hemiacetal or ketal alcohol acid. You replace the hydroxyl group on the carbon with the OR, 2 oxygens with OR triple prime, and that comes from the alcohol you're reacting with. So here, everything else stays the same, and the R group is ethyl, and this is what you get. Don't forget to put this bond here. It better be there, I'll mark it wrong. And here I put a different R group, cyclohexane, and if I move the screen or the videos out of the way, that's what you get. Now, let's talk about some reactions. If I take sucrose and react with acid and water, like in your stomach, what are the products I get? Well, this is this acid hydrolysis of an acetal or ketal. Get back the aldehyde or the ketone you would have used to make that, plus the alcohol. In this case, you get back glucose and fructose. And remember, starch, acid, water, you get back glucose. Now, to amylose this X out, I got overboard. That's the starch, so you get glucose. And do I have amylose? Nope, that's it. Oh no, we're done. Not really. Let's do a few more things. Speaking about a few more things, hold on. Ah, that's why I didn't. I never opened it up. You know what I forgot? Oh my goodness, it's near the end of the semester. I did things out of order. I should have done the review first. As soon as we do this, I'll do the review. Sorry. All right. That happens once in a while, like once a semester, and it happened today. All right, let's look at some things you should know for test number 4 and also leaving my class, meaning the final. Describe with words in a general reaction what happens in your stomach when you eat a fat or oil. I'll let you try that, and then it's my turn. For those who came in late, I've at a new internet speed. Hopefully everything is looking good. I also dropped my cable, which I don't need because anything I watch on cable, I found out I can get for free on the internet. Anybody wanting to know about that, see me during my office hour. I have two friends who are really pros at finding those things out. And they've been on my case for a long time. Why are you still paying for cable? You can get that all free. I finally decided, you know, something over the weekend, let me check. They were right. All right, everybody's done. My turn. How do you describe with words and a general reaction what happens in your stomach when you eat a fat or oil? In your stomach is acid. In your stomach is water, and we call that acid hydrolysis. And what's the functional group in a fat or oil? An ester. And what's the general reaction? You learned for test number 3.
Dr. White, are you writing? Because we can't see your screen.
Oh no, I thought somebody should have told me that. Now do you see it?
Yes, thanks.
Did you see it earlier when I had the question on there?
No, I wasn't sure if we were supposed to see it or not.
Oh no. Well, let's start again. Is this Monday the 13th? Anyways, describe with words and a general reaction what happens when you in your stomach when you eat. I better not walk under any ladders or stuff like that today. But anyways, a fat or an oil. And the answer is, oh, look, I already wrote it. Am I good or am I good? It's in your stomach. You have acid, water, meaning hydrolysis. And what's the functional group of in an ester? In a fat or oil, an ester. And now the general reaction, ester, fat or oil, what do you get back? The carboxylic acid you would have used to make that ester plus the alcohol. All right, let's do B. why don't you write down, describe with words in a general reaction, what happens in your stomach when you eat a carbohydrate? If you had the good stuff in the last day or so, like potato chips, French fries, all the things I shouldn't have, and I haven't. Oh, I miss them. Not really. All right, I have to get to work. So what's in your stomach? By the way, thumbs up. Can you still see my whiteboard? Thumbs up. Thank you. All right, there's acid. There's water. So the reaction is described as acid hydrolysis. Had a brain freeze. That's one word I sometimes spell wrong, hydrolysis. And what's the functional group that holds glucose together in a carbohydrate? An acetal. So it's acid hydrolysis of an acetal. And what's the general reaction? Well, you learned this for test number 2. Take an acetal, keep your eye on the carbon with the 2 oxygens. What's bonded directly to it? R prime, R double prime. Remember, R prime can be a hydrogen. You get back the ketone or aldehyde you would have used to make that, acetal or ketal, plus, and you don't have to put the 2 here, you get the alcohol you would have used from here. And that's how you do this. And this is something you should know leaving my class. Hint, hint, big hint, along with which we've gone over, you should know how soap works. All right, I messed up and I should have did a second, but it's done, it's done. Let's go through my review for test number 4. Well, if I go this way, this is fixed. All right, let's, since everybody see test 4 review on your screen. Thumbs up, people. Thank you. All right, test number 4 deals, first of all, with polymers. You should know, what is a polymer? A polymer is a macromolecule made up of repeating units called monomers. For those of you who can't read cursive, sorry, I just never had a chance this semester to rewrite these. I'll do it next semester, actually print them. All right, chemical property type of polymers. And there's 2 ways of describing the chemical properties of polymers. One is an addition polymer. An addition polymer only has 1 type of monomer used. And you should know example of that is saran wrap, Also, another example would be car tires or bicycle tires. Now, the other type of property based on chemical property of a polymer is condensation polymer. That's where you have two or more different types of monomers coming together. An example that would be a plastic water bottle, or if you happen to have a nylon jacket, those are all examples of items that contain condensation polymers. Now, when we talk about classification, you can classify polymers by chemical property, also by a key physical property. And the first one is thermoplastic. And a thermoplastic is a polymer, once formed, can be reheated and that should be and reshaped to form a new polymer. In other words, it's recyclable. An example of this is this, my plastic water bottle, or if you have a 2-liter or a smaller size of pop, tea, or anything that comes in those type of plastic bottles. All right, the other type is thermoset. And thermoset, once formed, cannot be reheated and reshaped. Once you make it and form it into the item it's supposed to be, that's it. An example of that is car tires. You can't melt car tires and make new tires out of the rubber. Can't. Another one would be urethane foam. Insulation. I should have insulation there. All right, next we talked about, notice how I still say we, I did, you listen, and that was fats and oils. And the title of this chapter is called Lipids. And what is a lipid? A lipid is a molecule from plants or animals that are soluble in nonpolar solvents, not soluble in water. And there's two types, saponifiable and non-saponifiable lipid. And a non-saponifiable or saponifiable lipid is also known as fats and oils. And a saponifiable lipid yields carboxylate anions of fatty acids in a reaction with base and water. Plus, you also get an alcohol glycerin. But the important thing is the carboxylate anions for this definition. Next, non-saponifiable lipids do not react with base or water. And we call those the steroids, otherwise known as your hormones. Now, you should know what's the difference between a fat and an oil. And a fat is a semi-solid or solid triglyceride at room temperature. And oil is a liquid triglyceride at room temperature. Now, here's a general structure of fats and oils, and notice it's a triester. Ester number 1, 2, 3. And this because you've got 3 esters in the same molecule, they undergo the chemistry you learned about esters. If I take an ester and react with acid and water, I'll get back the alcohol plus the carboxylic acid I would have used to make that ester. And since I have a triester triglyceride, I get this ester, this alcohol, plus this carboxylic acid, this ester, this alcohol, this carboxylic acid, this ester, this alcohol, this carboxylic acid, this glycerin, and you get 3 fatty acids. And fatty acids is shortened from fatty carboxylic acids. Now, just like you have acid hydrolysis of a fat or oil, you can also have base hydrolysis of an ester. So you can also have base hydrolysis of a fat or oil. And for this class, I'm only going to use sodium hydroxide. And as you know from test 3, ester, sodium hydroxide, water. You get back the alcohol plus the carboxylate anion, the carboxylic acid you would have used to make that ester. Ester 1 gives me this alcohol and this carboxylate anion. Ester 2, this alcohol, this carboxylate anion. Ester 3, this alcohol, so you get glycerin plus this carboxylate anion. Now, something I hadn't taught you for test 3, but in the real world we use, and that's steam hydrolysis of a fat or oil. And there are 2 ways you can catalyze a reaction. One is by using a catalyst, which we've done in some reactions, and the other, which we haven't done till now, is change the reaction temperature. For most, not all, but most reactions, when you double the temperature or increase the temperature by 10 degrees C, you double the reaction rate. And so instead of doing this with water, use steam, which is very, very, very hot water. You get the same thing as acid hydrolysis, but you don't need the acid because you're heating up the water. And here, ester gives you alcohol plus carboxylic acid you would have used to make that ester. And if we have a triglyceride, we have the 3 esters, and you get glycerin and these 3 carboxylic acids. Remember, ester number 1, hydrolysis gives me this alcohol plus this carboxylic acid, and the same for the other 2. Now, when it comes to fatty acids, the 2 main ones you should know the structure of. Hint are stearic acid, which is a saturated fatty acid. And notice I have 18 carbons and I have CH3, 16 CH2, my carboxylic acid. And that's stearic acid. Now, oleic acid is a monounsaturated fatty acid. Mono 1, unsaturated means double bond, because Mother Nature and all her work, including fats and oils, never, ever did a triple bond. That's something organic chemists did. All right, now, here we have oleic acid. It's got 18 carbons like stearic, but you have CH3, CH2 7 times, a double bond, and 7 more CH2s than a carboxylic acid. And if you notice, 7 plus 1 is 8, plus 8 is 16, plus 2 more is 18. By the way, that double bond can be cis or trans. Now, when we talk about double bonds in fats and oils, carbon-carbon double bonds, remember a long time ago in a galaxy far, no, at the beginning of the semester, I talked about saturated hydrocarbons and unsaturated hydrocarbons. Well, similar, not the same, but similar apply. In saturated fat, only carbon-carbon single bonds. Now, if you write only carbon single bonds, I'll mark that wrong. Why? Because if you look at this here, R can have, no, it can't have any double bonds, carbon-carbon, but this is a carbon-oxygen, which is not included in saturated or unsaturated. Now, an unsaturated fat has at least 1 carbon-carbon double bond. Remember, Mother Nature never did triple bonds. Now, since I worked in this industry, I figured I'd teach you a few things you should know. And that is tallow is beef fat, and you should know that. And there's 2 different types of pig's fat, white grease and yellow grease. And you should know that. Now, to make what I've been teaching you a real world, which makes it more fun, I came up years ago with a way of depicting tallow, white grease, and yellow grease, because you can use them essentially interchangeably, at least where I work, to make oleic and stearic acid. And how do we do that? By this presentation or representation. And here you have CH2O C double bond R sub S for sterile. We have this one, CHO double bond carbonyl R sub O, oleal, and another sterile. How can you do 50-50 approximately when there are three groups? You can't, but this is a good approximation. And therefore, if you take tallow and react it with sodium hydroxide and water, which is base hydrolysis of an ester, use this representation for tallow, white grease or yellow grease. First ester gives this alcohol plus sodium stearate. Second second ester gives this alcohol plus sodium oleate. And the third one gives this alcohol. You get glycerin plus sodium stearate. You can put the two there or not, because I only asked for products, and there are three different products there. And the same above with HCl and water and with steam. Since I got lazy, I better get unlazy. All right, why don't you do this? You're going to get three different products. What's the product or products for the following? I already gave it away. You'll get three different products. Your turn. All right, time for Dr. White to get to work. And remember the general reaction when you use steam, which as I have here is hot water, you get back the alcohol plus the carboxylic acid you would have used to make that ester. So ester number one, we get this alcohol, and the carboxylic acid would be stearic acid. Ester number two, you get this alcohol. Oops. You don't get whoops, you get one less hydrogen on there. I always do that with glycerin. And notice the R group is R sub O. And finally, this alcohol, you get this alcohol, or this ester, you get this alcohol. Plus, notice here, you'll get a second one of these, but how many different products? 1, 2, 3. Because we don't balance, so I'm just asking how many different products. Now, one of the things I would like you leaving my class to know how to do, how does soap work? First of all, in knowing how soap works, you should know that the general structure of a soap is a nonpolar tail, polar head. And when you're washing something like your hands, use water. But what's on your hand you're trying to get off normally? Dirt or grease. Water is polar, dirt and grease are nonpolar. And the whole key to this puzzle, the most important thing, how soap works is like dissolves like. Now, remember, polar things are soluble in polar things, other things, and nonpolar things are soluble in other nonpolar things. If you try and mix the two together, they don't want to be together. They'll be heterogeneous, separate, say, I don't want any part of you. Well, like dissolves like is an important part of the puzzle, because when you use soap and water, the soap molecules with the nonpolar tail will be attracted to dirt. The polar head wants to stay as far away. And what you form, and you should know, is a micelle. And now water looks at the micelle and says, oh, you're polar. It looks polar. And it says, I'm polar, micelle, you're polar. Let's go down the drain together. And they do. And that's how you get your hands clean. Now, when it comes to non-saponifiable lipids, we're talking about the steroids. And the only thing I asked you to do was learn how to draw the ring skeleton for all steroids. And you have a 6-membered ring, 6-membered ring, 6-membered ring up here, 5-membered ring there. Now, let's talk about carbohydrates. You should know, well, this I wrote down, but you should know what is a carbohydrate. It's a polyhydroxyaldehyde or a polyhydroxyl ketone or molecule that upon hydrolysis becomes a polyhydroxyaldehyde or ketone. Poly meaning many. Now, when we talk about carbohydrates, an important concept is chirality. And what does chiral or chirality mean? Handedness. And I talked about chiral objects. And those are objects with a non-superimposable mirror image. Achiral, A means without, chirality, handedness, are objects with a superimposable mirror image. And we went through that just a little while ago in the problem set. Now, an important skill you should have is, as we did in the problem set, ooh, deja vu all over again. It comes from Yogi Berra, famous baseball player and baseball manager. Anyways, carbon atom with 4 different groups or 4 different atoms or a combination of 4 different groups of atoms is called a chiral carbon. As in a problem set, you should know how to identify those. All right, enantiomer, that's the non-superimposable mirror image of a chiral molecule. I should have put chiral there. Now, one of the important things you should know from test number 2, you take an aldehyde or ketone, react it with alcohol plus acid, you get a hemiacetal, hemiketal. However, when the alcohol and the aldehyde or ketone are in the same molecule, you don't need a catalyst, they're in equilibrium. And here, this hydrox group on C5 reacts with this aldehyde, just like this react with that, to form this hemiacetal. And you should know, if I give you this, how to get the product. If I give you the product, how to do the starting material. And same thing for fructose. The one above was glucose. This is fructose. And if you have the same thing on C5 and alcohol, the ketone is on C2, and you form this hemiketal. This forms a bond to that carbon. And if I look at the clock, it's about time for a break. I can give you an extra 25, 30 seconds over 5 minutes. Shh, don't tell anybody. And I'll see you at 1:55. Bye now for 5 minutes. Helps so I turn on my mic. Time to get going. All right, we're talking about, or I was talking about the review for test number 4. And I was showing you the 2 equilibrium of glucose to its hemi-acetal form and fructose to its hemi-ketal form. And you should know this. Now, what I didn't teach you when we did it in aldehydes and ketones, we got a symmetrical acetal or ketal. But if you take an acetal or ketal reactor with alcohol and acid, you get an unsymmetrical. R triple prime is not the same as R. And if we look at the cyclic form of glucose reacted with alcohol and acid catalyst, this hydroxyl group with its carbon with 2 oxygens bond to it is replaced with OR triple prime. And that's the mechanism in which glucose molecules are connected together. I like this fancy, huh? Not. To make starch. Now, things you should know. Sucrose, table sugar, the white stuff you put on your cereal or in your tea or coffee, is made up of fructose bond to glucose, 2 molecules. Starch is a polymer of glucose. Lots of glucose connect together. Polyglucose. I don't that you know I'm not a carbohydrate chemist. I don't think that you ever use that term like I do. But if you take a lot of glucose and react the acid with them, like an enzyme, which is just most of our acid catalysts, you get starch. And note the linkage is an acetal or ketal bondage. So if I take sucrose, acid, and water, I get back glucose and fructose. If I take starch reacted with acid and water, I get back glucose because starch is glucose units linked together, where sucrose is fructose and glucose linked together. And as I mentioned during the problem set at the end of it, you should know how to describe with words in a general reaction what happens when your stomach when you eat a fat or oil. And with words is acid hydrolysis of an ester. Remember, fats and oils main functional group is an ester. And the general reaction is ester, acid, and water. You get back the carboxylic acid and the alcohol you would have used to make that ester. Next, what happens in your stomach when you eat a carbohydrate? And that's acid hydrolysis of an acetal. And the general reaction is here. And we have, with the words, acid hydrolysis of an acetal. Here we have an acetal or ketal, acid water. Get back the aldehyde or ketone, plus the alcohol you would have used to make that. In real life, both of those are connected to make up glucose. All right, any questions about test 4? Okay, well, it's time for, oh no, our time together is running down. It's time for the last chapter. And that last chapter is titled Amino Acids, Peptides, and Proteins. This will not will not be on test number 4, but there will be some problems on the final exam coming up in a couple of weeks. All right, first of all, what's an amino acid? Well, it's an organic compound that contains both an amino group and a carboxylic acid, otherwise known as an amino carboxylic acid, which was shortened to amino acid. I have one way of drawing it here. Let me show you a better way that's a little clearer. This is good, but this is better. If you look on the whiteboard, first of all, thumbs up, people. Can you see my whiteboard? Thank you. We have an amino group and a carboxylic acid. Now, in amino acids, and also in carbonyl compounds like ketones and aldehyde, the carbon, excuse me, bonded to the carbonyl carbon is called the alpha carbon. And amino acids, the NH2 group or the amino group is always on the alpha carbon. I'll say that again. In amino acids or anything else, the carbon bonded to the carbonyl carbon of a carboxylic acid, also aldehyde too, is called the alpha carbon. And in amino acids, the amino group is always on the alpha carbon. Which I have the same thing here. I just swapped R and NH2. Looks a little easier to follow the way I have it. Now, if we look at that alpha carbon, like I said, the alpha carbon of an amino acid group is bonded. If it is bonded to 4 different groups, when R is not hydrogen, which is called glycine, then they're chiral. And this is a chiral carbon, or carbon is chiral, and most amino acids are chiral. Therefore, they exist in 2 hands, 2 different ways, like your hands, and the enantiomeric pair. And let's give an example. And here's the alpha carbon. And if you notice, I have a methyl on there, a hydrogen amino group, and a carboxylic acid group, 1, 2, 3, 4, which makes this a chiral carbon. And if R is hydrogen, then it wouldn't be, because you'd have 2 hydrogens. And that's the only amino acid I think that's achiral. Is what, alanine? Glycine. I haven't really. The only amino acids I've worked with are what's going on in my stomach when I break down. Well, anyways, we're getting ahead of the game. All right, now, the following 2 slides, I'm going to turn the switch. Will this be on the test, or actually the final, to the opposition? But for other classes, you may need to know this. Now, amino acids contain both a basic amino group, remember amines are basic, and an acidic carboxylic acid group. And you know carboxylic acids are acids. Now, depending on the pH, and again, switches off, amino acids can exist as what's called a zwitterion. I'm using the German pronunciation, mainly because the word comes from German zwei, which is 2 ions, 2 ions. And a zwitterion will look like this. Notice a proton from the carboxylic acid goes to the amino group, acid base. And it still is a net zero charge, but this is called a zwitterion. And again, switches off, but a zwitterion is a molecule that has a positive charge on one atom and a negative charge on another, but has no net charge. All molecules have a net zero charge. All right, switches back on, click for the final, not just number 4. If you take a carboxylic acid and amine, remember R prime and R double prime, one or both can be hydrogen. And what do you get? An amide. If we look up here, ooh, I want Technicolor on you. I just did a generation gap thing too on you. One color. If you have a carboxylic acid and amine, you'll form an amide. But the rest of the molecule comes along for the ride. And notice how we form an amide bond between 2 amino acids. Now, switches off because you're dealing with a synthetic organic chemist, not a protein chemist. And that is the covalent bond between a carboxylic acid of one amino acid and the amino group of another is called a peptide bond by protein chemists. And I call it an amide bond because I'm a synthetic organic chemist. But the peptide bond is the amide bond between 2 amino acids. Now, switch is still off. What's a peptide? A molecule containing 2 or more amino acids, which the amino acids are joined together through an amide bond, which is called a peptide bond. How they got to that, I have no idea. Now, what's a protein? I think you're all familiar with the word protein. A protein is a peptide, amino acids linked together, bond together, which at least 50 amino acids are present and connected by amide bonds, what I call them, or peptide bonds, other classes. Why they picked 50, don't know, but they had a good reason, I hope. And that's called protein. And you notice that's one of the major food groups. Have your protein so you have strong muscles, among other things that will help. And that's just amino acids linked together, 50 or more, to form a molecule. Ooh, time to scare the students. Not really. Everybody, take your index finger, take your back of your hand and touch it. Your skin is a giant protein, and it's made up of amide bonds, peptide. So when you go like this, you're touching a lot of amides. Now, how do you make a protein? You react a lot of amino acids together. Now, one thing I neglected to talk about, bad Dr. White, if you look at the reaction I have on this slide, notice this end, I still have an amine group, and this end, I still have a carboxylic acid. So you can hook to other, bond to other amino acids and keep on building up. Well, now that you have your protein, what happens when you consume a protein? Good question. Thank you. Well, in your stomach and intestines, and remember, Dr. White's an organic chemist. Last biology I took was freshman year of high school, but students corrected me. This happens not only in your stomach, but also in one of your intestines. I forgot if it was large or small, but it also keeps on happening. Your stomach breaks down proteins to amino acids by acid hydrolysis of an amide, a peptide bond. And remember the general reaction, amide, acid, and water. You get back the carboxylic acid plus the amine. No, because you're an acid, the amine salt of the amine you would have used. And this breaks it down. So I just have 2 amino acids hooked together. You could have 50, and it does the same thing. And first of all, this one right here is just an amine. It won't be involved in this red part of the reaction, but an amine is the base, and you'll get the amine salt. Now, this one, you'll get back the carboxylic acid. Now, R prime and R double prime can be hydrogen. And in an amide, as you learn for test number 3, if I react an amide with acid and water, and I'm using HCl because that's the acid in your stomach. And I'm always amazed that your stomach and my stomach have cells that make hydrochloric acid. And what you get back is the carboxylic acid plus not the amine salt of the amine, and in this case, this is the carboxylic acid, this is the amine salt. All the rest of it is carried along for the ride. And that's how you digest a protein. So if you had a hamburger, hot dog, tofu, or anything else with protein in it, this was going on in your stomach and small intestine, and maybe even right now. Uh-oh, I finished a chapter. That was quick. All right, let's go through 3 things you should know leaving my class. Deja vu again. Why don't you try this one? Then I'll do it. You should know what happens in your stomach when you eat a fat or oil and how to describe it with a general reaction and words. All right, let's do it. What's happening in your stomach? We have acid and water, so it's acid hydrolysis. And what's the functional group in an acid, fat or oil of an ester? And what's the general reaction? Ester, acid and water, and you get back the carboxylic acid you would have used to make that ester plus the alcohol you would have used to make that ester. Next, let's do how do you describe with words in a general reaction what happens when you eat a carbohydrate? And what's in your stomach? Acid and water, so the reaction is acid hydrolysis. What's the functional group in a carbohydrate? An acetal. And what's the general reaction? And that is, whoops, getting ahead of myself. Acetal or ketal, water. Keep your eye on the carbon with the two oxygens. All right, you take an acetal or ketal reactor with acid and water, get back the aldehyde or ketone plus the alcohol you would have used to make that acetal or ketal. And then today you learn the last part, which I'll do. What happens? How do you describe with words in a general reaction what happens when you eat a protein? Well, what's the key functional group in a protein? And that's an amide, otherwise known as the peptide bond. And what's in your stomach? Acid and water, so it's acid hydrolysis of an amide. By the way, in England, they call it amide. I always found that cute. They always tried to correct me. Oh, you Americans. Because I worked for a company, a couple of Anglo-Dutch companies. And what's the general reaction? I take an amide, react it with acid and water, and I'll use HCl because that's the acid in your stomach. You get back the carboxylic acid you would have used to make that amide, plus the amine salt of the amine you would have used. And remember our prime, our double prime, one or both or none. And that's how you do it. So I think I've covered the three main food groups that other people think about. You know, there are other main food groups like potato chips, French fries, beer, wine. But anyways, you should know the three major food groups, how to describe with words in a general reaction, leaving my test, my class. The first two you need to know for test number 4. All three you need to know, hint for the final. And that is A, if you eat a fat or oil, what happens in your stomach? Acid hydrolysis of an ester. The key functional group in a fat or oil is an ester. And here we have ester, acid, water. Get back the carboxylic acid plus the alcohol you would have used to make that ester. Carbohydrate. What's the key functional group in a carbohydrate? Acetal. And now you have acid hydrolysis of an acetal. And here you have what? Acetal, acid, and water. You get back the aldehyde or ketone plus the alcohol you would have used to make that. Now in glucose, these are connected together by a chemical bond. And finally, what I taught you today was what happens when words in a general reaction when you eat a protein. And a protein, the linkage that holds the amino acids together is an amide linkage, otherwise known as a peptide linkage, which I'll never ask you about peptides in my class, but other classes they might. And here, what's the key group that holds together protein or amino acids in a protein? Amide. In your stomach, you have acid hydrolysis of an amide. And the general reaction, amide, HCl, water, you get back the carboxylic acid plus the amine salt of amine you would have used to make that amide. What's your question? One sec. All right. Now, a couple things. Remember I said we got way ahead of myself because I cheated. Some of the time, which I would have let you out earlier during lab times, I used for lecture. So we're about an hour ahead of ourselves, but I do have a few things I want to talk about. Now, a couple of things. How many of you ever heard of the company called Neutrogena? Nobody? Oh my goodness, I see someone has. And they're a company that makes various personal care items. Let's see if I can find them. And if you notice, they have a lot of skincare, makeup and all that, and facial cleansers. And if you look at these, makeup remover, no, I don't need 15%. Have you noticed all nice makeup I'm using? Not. Ooh, fake beard. Uh-oh, not. But anyways, ooh, let's see what's in deep cleaning. Thought I saw where they were going to show you. All right. You notice they have the active ingredient salicylic acid. How many of you ever heard of what they call it? An acid treatment. What they call, somebody help me out. When they do acid treatment of your face, there's a name for that.
A chemical peel?
Is this spa?
That's it. Thank you. Chemical peel. What you're really doing is reacting the amides, your skin, with acid. And part of this has got a small amount of salicylic acid. Now, if we look at the ingredients, water, sodium C4, C16, olefin sulfonate, that's long R group, non-polar tail, polar head, soap, and other soaps too, and other things. I don't know why they put a sweetener in there, and other things, potato starch, so I wonder how that helps. And essentially, this is a soap and an acid peel at the same time. Now, the reason I brought this up is, and let's see if I can find another product. Here we go. Let's see what's in here. TEA sodium tallowate, essentially soap. Now, I worked for a company that sold them the tallow fatty acids and glycerin and cocoa fatty acids that they used in their products. Also, sodium oleate comes from oleic acid and different things with sodium stearate. And the reason I brought up Neutrogena was, interesting enough, Neutrogena, when I worked for Unichem Chemical and they bought fatty acids from us for their products, they always had the highest standards. They meant they wanted the best quality and they paid for it. And you pay for it too. Now, the thing that brought to mind, which I wanted to get to, is what happens if your bathroom sink gets clogged? Do you call a plumber? No, you don't have to. You use the following. All right. Earlier, I talked about how to get your kitchen sink free of fat and oil using hair and grease cleaner. And this is a mixture of sodium, potassium hydroxide, and some water. And how does it work? Well, there was base hydrolysis of an ester. How does this work on hair? Well, let's take a look. Hair is a protein. I don't think you can eat it and stay alive. Ugh. You get a fur ball then. Oh, Dr. White made it funny. But anyways, what's hair? An amide, polyamide. And the peptide linkages are really amides. So if I take, and let's just use sodium hydroxide, for example, and water, what happens is you break it down back to the carboxylate anion of the carboxylic acid you would have used to make that amide, plus the amine that you would have used. And an amino acid, these are connect together. So what you've done is you have this long hair, you've broken it down into small amino acids, which get flushed down the sink. And that's how you break it up. Now, one of the things, this reaction up here, we didn't do it face to face, but there are two reaction labs where we use very strong acid H+. And when you see me, if you were ever face to face doing that, I'd be at DEFCON 5. Anybody ever hear the DEFCON readiness level of the US military? It's DEFCON 5 is the highest. It's been described, you're holding a gun, you're pulling the trigger on atomic weapons we're talking about, and the hammer is just about ready to go forward. That's how dangerous. In the United States, I think the highest has been DEFCON 3 during the Cuban Missile Crisis, which was quite scary. But when I teach a lab with acid, I'm at DEFCON 5 trying to watch all students at the same time. Why? Because if you get acid on your skin, you get a real bad acid burn. Why do they call it an acid burn? Because it feels like if you put hot metal on your skin. I've never had it, but unfortunately at the other school, a student didn't pay attention and follow my instructions and put a whole milliliter of acid on his forearm. And that's before I had him wearing long sleeve tops or lab coats during that. And even though I washed it off with cold water, within 1 minute, it damaged his skin very badly. We got medical attention for him. He was all right, but he had a nasty scar right here, like a burn scar. And that's because of this reaction. Your skin is enamel. Quick question for those of you who remember. Did I talk about why you should never debate chemistry at Home Depot with anybody? Did I tell that story? I don't think so, so I'm going to tell it. Anyways, the day I found I think I did, but I'll do it again because it's a nice story. When I had my drain in my kitchen sink plugged up and I'd had the rotor-rooter guy out 3 different times and I finally gave up on him, I went to Home Depot and asked the guy, I was looking around, they have a whole wall of drain cleaners. I'm picking up the bottles and all of them look like, to me, I didn't pick up every one, but about 5 or 6 different brands just had acid and water. So a nice gentleman who worked there, and they're really the Home Depot by my house, and this one's on Barrington Road. I think that's Schaumburg right there, Streamwood, one of the two. They're really good, and they have been for many, many years. They're very helpful and knowledgeable. So a guy comes up to me, a gentleman who works in that area, asks, can I help you? I said, of course. All these drain cleaners, which one did the plumbers buy? And immediately said, this one. And it was that quick, he said that. This is what they use. So I picked it up. That was the hair and grease. And I looked at the back and it said sodium hydroxide, potassium hydroxide. Let's see if I can pull up. Aha. You see here, SDS on here. That's the MSDS or safety data sheet. Which doesn't want to pull up. So much for that link. Let's try something. All right, got it the other way. And everybody see that on your screen? Hold on, let me make sure. It shows you as 34 to 50% sodium hydroxide, about 1 to 3% potassium hydroxide, essentially potassium hydroxide and sodium hydroxide. I looked at the label and I actually saw that on the label and I said, oh, this contains base. And immediately he said, no, that's acid. It's got acid. I said, excuse me, I have a PhD in synthetic organic chemistry and it's a base. And he said, no, it's an acid. And all of a sudden dawned on me, this guy helped me. I think it'll be good product. And why am I arguing with someone who doesn't know the difference between an acid and a base? I thanked him and said, well, whatever it is, thank you. I bought the bottle and it worked real good. And recently, after living in my house for over 20 years, my bathroom sink clogged up. It was draining real slow. And I guess it was me shedding hair or something. Ouch. And so I used it on there and it's like brand new. And that stuff works. And why does it work on hair? Because that's base hydrolysis of an amide. Now, I'm going to do something I haven't done all semester, but I said I cheated during this last couple of weeks where I should have let you out early on Wednesdays, but I did some more lecturing, a lot more, which I think helped you. I'm going to let you out early today. But before I do, on Wednesday, I'm going to have a super surprise. I'm going to take you on a tour of a chemical plant, something almost all Americans never get to see. Most people in the world never get to see. I'll take you up, but I will cut it out of video. So be sure to come to class on Wednesday so you can see what it's like to work in a chemical plant. With that, I'm going to let you out early because we're done for today. We're almost done for the semester. Oh, that's time flies when you're having fun with organic. With that, I'm going to say a little early today, but we're caught up. Don't forget, if you have questions, come to my office hours. Also, don't forget, Wednesday after the lab, our last lab, I will send out the password for test number 4. I think about sometime tomorrow afternoon, I have it set up on Blackboard, or tomorrow morning, Blackboard, wrong school, D2L, that you can download test number 4. And once you get the password on Wednesday, you can take it and you have until Thursday to finish up and upload test number 4. With that, I'm going to say, Gang gesund, goodbye.